Welcome to the fourth lecture of this course. In this lecture, we will see the importance and working of the anti-malware protection module of the Cisco Firepower. The Cisco Firepower appliances provide the advanced malware protection for networks. This feature, as the intrusion prevention system we studied in the last lecture, utilizes the SNOT engine for its working. As we studied in the SNOT architecture, it can understand the network protocols and also carve out meaningful information out of the network traffic. This information is critical for the anti-malware protection module to work properly. The AMP can detect files based on their hashes, local malware analysis powered by the signature database on the device, as well as submitting the file to Cisco Threat Grid for sandboxing and dynamic analysis. It can also block file transfers based on the file type as well as based on the malware verdict. One more thing that you need to understand is that you are going to have things that give you simple one-to-one signature-based matching. You are going to want to catch the low-hanging fruit quickly so that you don't have to go hunting for signs of breach or indications of breach. You are going to be able to catch those things and move forward. But then there are other technologies that play into this space. Multi-fingerprinting, which looks for families of malware, things like machine learning, which will look at how files execute and their behavior, detects things like zero-day malware as it slides into your environment. And there are other point-in-time technologies that we could spend time to really dig into. Advanced analytics, dynamic analysis, but consider them all point in time. They're going to provide some value at a moment in time, but you don't need to be looking beyond that moment. All point in time detection is less than 100%. According to a study, more than $7 trillion have been spent on the network and cybersecurity in the last decade, but still, the success rate for hackers is more than 95%. With advanced malware protection everywhere, organizations can deploy a security architecture that shares information and provides an integrated threat defense from network edge to data center to endpoints across all attack vectors. Now we are going to see the actual program view, showing the path of a file across multiple devices. By hovering over an event, you can see details like where the file came from originally, when was it downloaded, what type of event is this, the program name. All this information is just a mouse hover away. Here we see the first event. A file with an unknown disposition is present on IP 10.4.10.183. It enters the network by being transmitted from the same IP to 10.5.11.8, and the file has a disposition of unknown. We did not know it was bad, but we do know that it was introduced by a user using Firefox, downloading this file over HTTP using this web browser. That file then sat on 10.5.11.8. After a period of inactivity, the file transmits down to machine 10.3.4.51 over SMB, the application protocol listed in the gray box. So it starts transmitting using internal Microsoft file sharing protocols. This file has not yet been identified as malware, and so its disposition is still unknown. The file copies itself onto a fourth machine a half hour later using the same application protocol. At 6:14, we see a retrospective event turn up, so it appears for four machines at the same time. Our disposition thus far has gone from something we think is unknown to now known malware. So we have alerted each of these four machines and the defense center that malware has been found in the environment to enable the user to track how that file propagated around the network and understand the scope of the breach. This machine here, 10.5.11.8, we can see that it has the Fire app endpoint connector installed. We know this because immediately after after that retrospective event was raised, the endpoint quarantined the file. So by having the connector on the endpoint, you have the ability to clear up and remediate and quarantine that infection on the endpoint near in near real time. Later, the file once again tried to move around the network, this time once again by someone trying to send the file over HTTP using the application Firefox. This time, because the file is now known to be malware, this transmission was blocked. So, this is the end of this lecture. We saw the working of an advanced malware protection module of Cisco Firepower along with the actual view of the program interface and understood the level of details it can provide for better security. In the next lecture, we'll cover the threat intelligence and application visibility and control module of the Cisco Firepower.